Welcome to From the Crow's Nest, a podcast on electromagnetic spectrum operations, or EMSO. I'm your host, Ken Miller, Director of Advocacy and Outreach for the Association of Old Crows. You can follow me on LinkedIn, or you can email me directly at host@fromthecrowsnest.org. Thanks for listening. All right, well, welcome back, everyone. We are here on April 23rd, the end of April already. And I think we are squarely getting into spring here on the east coast of the U.S. It's been, winter's been holding on for a little bit, but I think we have a good patch of weather coming up here. I just got back from a whirlwind trip to Boston, D.C., and San Antonio, Texas this month to visit stakeholders. It was a great visit. All the way around. The military stakeholders down in San Antonio makes that region one of the most important centers of gravity for the EMSO community. So it was great to get down there. Once again, I try to get down there at least once or twice a year just to kind of keep those relationships going. And it was really a great opportunity. The biggest takeaway, honestly, from all the meetings I had this month, it all comes down to education and training, quite frankly. It came up every single time about the need to have more seats filled in the agencies, as well as a better training from basic EW all the way up to more specialized technical expertise. We have some of the smartest people in this community. We really do, and they're fantastic, but we simply just don't have enough. And as the years go by, we've been talking about this for decades. As the years go by, we continue to lose more and more talent via retirement and reassignment. And so we have a lot of catch-up to play. So that was definitely on the forefront of a lot of people's minds. I am sure that those conversations will continue moving forward. It's all going to come down to funding and time. And, AOC is going to be engaged a lot of different ways on this front, far beyond the podcast. But we'll try to use the podcast to keep everybody posted on things the best we can. The next stop on the docket is AOC Europe in Rome, Italy. I know that these are all very tough assignments that just keep coming onto my plate. So all the listeners can live vicariously through me. That's more than fine. I'm happy to take on that cross. But the podcast will be at AOC Europe in Rome. We'll be conducting some interviews with speakers and exhibitors from the show floor there. We'll be posting everything on LinkedIn and social media. So if you cannot attend AOC Europe, know that you can follow us on social media, all the discussions that are happening there. There's a lot of developments. For those of you who are AOC members, our episode last week, when I had Dr. Tom Withington on the show, we talked a lot about the new EW coalition being formed by the European defense agencies. That's going to really potentially transform the ability for Europeans to be interoperable on EW, work with the U.S. as necessary. But this is really a European-driven initiative, and it's really great to see. I think that is a very positive outcome over these last few months. And so we'll be talking about that a lot in Rome as well. So please follow us on social media, engage with us via email, keep in touch electronically. We always enjoy hearing from our listeners on that. Also, and related to that, moving forward, I do a lot of travel for AOC for advocacy, not just for the podcast. But if you are listeners, especially if you're active duty, in a particular warfighter community, a squadron or group or something, and would like to be on the podcast, one of our goals coming out of this year is to do more human interest stories on the podcast, where we can kind of give an insight into just the life and challenges and missions of the warfighters out there. So we'd love to come visit your area. We can set up a virtual show or a live show, and just have a good discussion and bring that to our listeners as well. So if that's something that interests you, please reach out to me on email, host@fromthecrowsnest.org. Happy to see what we can pull together for you if that is of interest to you. All right, so in today's episode, I am very pleased to have with me Dr. Raffaele Licursi here to discuss Metasurface-driven EW drone swarms to tackle multifunctional and cognitive radars. One of the great things about my job here with the podcast is I get to take these topics that on the surface just seem mind-blowing and make them more accessible for our listeners. And this is a fantastic topic. Really, and Dr. Licursi, you'll see, is extremely accessible in this topic. But if you really want to kind of think what's on the horizon for EW, this is an area that is going to get a lot of attention because it really makes EW and the capabilities that we can bring from electronic attack and electronic protect efforts, it makes them even more adaptable and agile real time to the threats that are out there. Just fascinating what we can accomplish. And so the challenge as always is to get this technology into the field, tested and operational as fast as we can. So it was a great conversation. And so pleased to bring you Dr. Raphael Licursi. He is the author of Metasurface-Driven Electronic Warfare. He is an antenna radar researcher and electronic warfare consultant. He's experienced in both hardware and software challenges in the EW world, and so he now focuses on innovative use of metasurfaces in this context. And so without further delay, I welcome Dr. Raphael Licursi from the Crow's Nest. Dr. Licursi, thank you for joining me here on From the Crow's Nest. It's great to have you on the show.
It's my pleasure, Ken. Thank you for the invitation. Thank you for the opportunity of addressing this amazing audience at AOC.
Yes, you're calling in from Paris, France. I have to be honest, I'm on travel on the road here in San Antonio. So I think if you looked up the absolute opposite of Paris, it would be Texas. So we're reaching the entire global audience here today. But I want to talk a little bit about where you're at right now and where you're currently doing your research.
Yeah, I'm here in Paris. We are in a particular geopolitical moment, let's say. So we have many events happening around us here in Europe. And the latest events can show us how technology is evolving so fast. And we have different fronts of development in this technology. And I'm placing myself in the research of metasurfaces to apply in the next scenario of warfare.
I think that there's a lot of momentum in Europe now for advanced technology, advanced solutions, capabilities that are native to European defense base. This is a topic I don't have much exposure to, so you're going to have to kind of walk me through. And I know a lot of our audience, they listen out of kind of just a general interest. So let's define some of the terms here first. When you say metasurface driven anything, talk a little bit about that concept and what that means in terms of what your research.
Yeah, to understand what would be a metasurface driven anything, it would be nice to have a clear view about what a metasurface is. And the easiest way of doing that is to compare metasurface in front of normal materials, normal surface, let's say. So I really like to do this comparison. When we take a look at a reflective surface, for example, metal, and here they are, reflective to electromagnetic waves. Metal reflects waves with specific properties. And if we think about that, we can see that we need to accept what nature provides to us. If I want to build an antenna reflector, for example, I need to use metal. I need to shape that object to provide me specific capabilities, considering the properties that metal gives to me. So we don't have degrees of freedom. In the end, we build a device that's not the most convenient one. Maybe it will be bulky. Maybe it won't have aerodynamical profile. We should adapt our aircraft, for example, or a spacecraft or drone to those conditions. So what Metasurface adds to the current scenario? It adds in the sense that now we control the properties of the material. Instead of having metal that will provide me something, some properties, and I need to shape my final object, now I can use something that I call metasurface and will provide the exact reflection properties that I want. In this way, instead of shaping the final object accordingly, I can define a specific shape that fits my project, my drone, my spacecraft, my aircraft, and then choose the properties of the metasurface that will lead to a final result. So that changes many things in this scenario.
You mentioned something that's very interesting. You said you kind of have to work with what nature gives you. And I remember AOC conference a couple of years ago, we had someone basically saying that whatever you want to do in electronic warfare, you can find it being done in nature in somewhere. And everything you need to learn is already occurring in nature. And sometimes we look at nature as confining, but you're basically saying, look, diving into the natural properties of everything and what nature provides is actually opens up the flexibility for you to develop a particular result. Is that kind of what you're talking about in terms of working with what nature gives you and working with the natural properties of various surfaces or materials?
Yeah. When we study in detail the interactions between electromagnetic waves and matter, we can see that the displacing of the molecules and everything has a final effect in the fields that we receive from those interactions. And it turns out that we found a way of creating similar interactions by shaping small pieces that we call unit cells. And through the design of these unit cells, these shapes, we can emulate the behaviors that we want, that is arbitrary behaviors. And most interestingly, we can also use over these unit cells reconfigurable components. And by controlling these components, we can make the interactions dynamic. And again, we can, by using a little bit of our creativity, we can come up with many new properties not available 20 years ago, 10 years ago. So we just shifted from a position where we were a little bit passive in front of electromagnetic phenomena, and now we control what happens. It's sort of a way of tailoring electromagnetic wavefronts. And all these through the design of small pieces, small unit cells that are seen by the electromagnetic waves as normal matter when actually is artificial matter.
Would you say that work being done in this field, it opens up the door to possibilities in terms of what you can create electromagnetic effects using, because you're not confined to the materials of the past? It creates a whole new realm of potential responses.
Exactly. Let's go for a concrete example. Imagine that in the past, we wanted to create some lenses to over an antenna, and these lenses can be built with resin, and we are going to shape the resin so as to focus the waves at specific directions. So now imagine that instead of using this resin and this specific shape, we are going to put a transmissive metasurface over the antenna. And at different points of the metasurface, we create the unit cells to interact differently with the waves in a way that we focus each small amount of energy towards specific directions, and we have this final effect. So in the first years of metasurface development, this was done using static devices. It means that we used to build those surface only with metal parts and dielectric material. But nowadays, instead of doing that, we can add electronic components that we can act over and focus these waves dynamically in our operations. So we're bringing reconfigurability to the physical layer. So when we regard the scenario, the electronic warfare scenario, some years ago, some decades ago, reconfigurability was something uncommon and really advanced. In the last decades, software brought this asset, that is reconfigurability, to the scenario with all force, let's say. And now reconfigurability is reaching the hardware. Reconfigurability is reaching the physical layer. I gave you the example of an antenna that could actually be done with phased arrays in the past, but the same example, other examples can be explored in stealth technology, for example. Imagine that we have a platform which can be stealth or not. We can define that on the fly.
That's amazing. So let me ask you a question on this. A lot of times throughout our episodes on the show, we turn to the necessary resources, cost, time, attributes of that nature. It would seem to me that this would have a positive effect on potentially on development time as well as like access to resources. So like the supply chain of the technology. Talk a little bit about kind of some of the efficiencies in terms of creating that capability that using this technique allows you to have.
So Metasurface can bring the reconfigurability assets to the physical layer. And the impact of this feature is that instead of creating new systems, designing new systems to counter adversaries, now we can reconfigure existing ones in the speed of light, let's say, being much more effective to counter those adversarial systems. If we regard this capability in the context of a cat and mouse game, it means that we're going to hold dominance of the electromagnetic spectrum more efficiently when we can achieve the right counter for the adversaries much faster than them.
And so by using this technique, then when a new threat pops up that requires a new waveform or a new response, you can reconfigure attributes in existing systems to respond more quickly than having to develop a whole new solution.
Yeah, exactly. So Metasurface will improve the innovation rate by introducing reconfigurability at the physics level. But what's even more interesting in the scenario now of Metasurface is that we can make platforms and even the environment reconfigurable. And this is something that we couldn't even envision that in the past. It's easy to understand that if we take a look at the 6G mobile communication standards, the 6G that is already being prepared right now. So the 6G will use Metasurface in the physics level to guide waves, let's say, within cities. In the 6G, we are going to have Metasurface installed over the walls of buildings. And within cities, we have something that's called the multipath propagation. Waves, they hit many walls, they reflect over many walls, and they don't arrive directly in the user receivers. So that's what we call the multipath propagation. When we add Metasurface, we can just control the channel. That's something new.
As you're explaining this, my mind is going to a conversation we had a while back. As we advance in 5G, 6G, moving kind of up frequency and work is being done in like millimeter wave. Obviously, the propagation of those signals becomes a little bit more unreliable as you move up. So one of the talks is like if you're going to go up to like millimeter wave or higher frequency, you're going to have a lot more nodes to kind of receive and transmit that signal because it can't travel distances and you kind of it loses fidelity. So using metasurfaces, are you saying like as you can kind of put the metasurfaces around your environment, is that a way to kind of control and enhance that signal as you move up to kind of maintain the fidelity of the signal you're transmitting?
Exactly. What happens nowadays without Metasurface is that we spread energy over many directions. So until now, without Metasurface, we could control the transmitter side and the receiver side. So nowadays, what we do is to optimize the communication chain. There is a feedback in this process, and then in the transmission, we apply some actions. We apply some actions in the receiver so as to improve this communication link, let's say. But the channel we don't control nowadays. It means that some energy can be spread towards the directions that we don't want. When we add the metal surface, we are adding extra degrees of freedom. And this is the way of formulating the problem from an engineering perspective. But from a practical perspective, we just can see that the metasurface, they will reflect waves in an optimal way to the directions that will increase the receiving of those signals. But here we are talking about increasing signals. This is a civilian problem, let's say. What if we decide, instead of increasing signals, degrading signals so that the opponents can't intercept our signals? So this would be the way that we can shape the environment in our favor.
The promises that innovation holds is exciting. I'm on travel this week. I'm down in San Antonio, Texas, where a lot of EW stakeholders are located. And we were talking a lot about kind of the challenge that, we're not just talking, globally. We're not talking two major global threats or anything like that. We talk a lot about Russia. We talk a lot about China, obviously, but every region of the world has potential flashpoints and conflicts. And so when you're trying to create systems that can adapt to environments anywhere from North Africa to the Arctic to Eastern Europe to Indo-PACOM, you're going to need that flexibility. And I can kind of see how using this approach, even when we're talking about advanced fighters or fifth gen aircraft, if you're moving to the next generation, it can take years and years to develop the attributes of that system that are obsolete by the time it actually reaches a field, whereas using this approach can kind of keep those attributes current.
Yeah, yeah. So it looks like the trends of nowadays are a little bit different from one decade ago. So the trend nowadays is to have distributed, scalable, specialized systems. I love the talk that you had with Brian Clark about this. He's crystal clear when he explains about these questions, this matter. We cannot build a specific technology to apply everywhere in the world anymore. Not only specific regions, they have different features, but specific situations in the same conflict, they represent different conditions. And if we want to prevail, we cannot use general systems anymore. Even in, let's think about an electronic support system, a conventional electronic support system, trying to detect an LPI radar before it's being detected, like before its platform is detected. This is the traditional EW combat. Mm-hmm. Nowadays, the radars are becoming really advanced and really hard to detect. And if we want to use a traditional support system, really wideband that wants to detect everything with antennas that are not the best ones in terms of efficiency, but they are the best ones in terms of coverage. So this generic approach, the things that will detect everything, nowadays presents many disadvantages in front of the modern radars. So even in the traditional electronic support, it's already clear that we need to sacrifice coverage, we need to sacrifice everything that's general and to create specialized systems. We can also take this conversation for an economical point of view. After the Cold War, when things became more stable and we believed that we would not have large scale conflicts anymore, there were less reasons to put money on defense. Let's say the threat perception was lower than before, than previously. And then we could afford the idea of creating generic platforms that could handle many missions. Mm-hmm. So now we have a huge range of different missions of specialized and high performance systems. And those systems and platforms, they are not the most appropriate anymore. So the only solution nowadays is to create specialized counters against specific threats. And this is possible only with investments.
As I mentioned at the top of the conversation, you are teaching a course on this at AOC Europe, and you have a book out by the same topic, metasurface-driven electronic warfare. As we reach the end of our time, talk a little bit about where you kind of feel your research is going, kind of looking on the horizon. You mentioned cat and mouse. There's a circular image to the cat and mouse analogy, but it's actually more linear. It's advancing at speed. Where do you see this research going, or what are some of the areas that you're going to really focus your attention on?
I'd like to introduce another analogy here. I tend to see defense forces as octopuses. And in the past, we could see the octopuses as a brain controlling strong tentacles. Mm-hmm. It turns out that the trend's not this anymore. We don't want a single brain controlling few strong tentacles. What we want nowadays is to have many, 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 many weaker tentacles that we can control by a smarter brain. What I can see is that the tentacles, they are composed by metasurface and kinetic elements, let's say, and this is controlled by the brain, which nowadays is AI. So we have many advancements in AI. It's becoming each day more powerful. I don't believe that a strong force will be the one that focus on the tentacles or on the brain. The strongest force will be the one that can create the cleverest ways of building the octopus as a whole.
Would you say that, I mean, with the advancements in artificial intelligence, machine learning, deep learning, and progress in this topic of metasurfaces, it almost sounds like AI and machine learning could kind of build the next system for you because it can identify at a speed and depth that the human brain can't work, could basically design your product for you. It would be able to speed up the time because it's not confined to basically a human mind.
AI and Metasurface, they can work together at different levels. For example, I can incorporate Metasurface in a system that's driven by AI, and the AI will control the Metasurface so as to provide specific behaviors and that will really bother, that will disturb the functioning of adversarial systems. This is one thing. The other thing is if we use AI to design metasurfaces, there are some approaches to do that. Designing a unit cell that will provide you a specific behavior is not trivial. Nowadays, how do we do that? Nowadays, we design the first one, we learn how it works, and then we do another research. After some years of experience, we have a gut feeling on how to start a specific unit cell to obtaining specific behaviors. But AI is contributing in this area as well. There are some approaches where we can ask an AI model to design the unit cell, making things faster. So this is roughly speaking, two levels of association between Metasurface and AI. One, AI controlling the Metasurface in the operational scenario. The other, AI contributing to the design of Metasurfaces.
I kind of feel like we're almost on the verge of a whole new Marvel comic universe of movies here. This technology almost seems a little bit, it's hard to get your mind around, but really exciting stuff. Really appreciate you coming on the show to talk about this. On the other side of your course, I think that this is a topic that we could probably want to look at more in depth. And so I'd love to have you back on the show, but really appreciate you kind of opening up our minds to this world that you're working in, and I hope this continues to kind of open up a new set of solutions.
Yeah, it's my pleasure. Whenever we talk, we have good conversations and develop these ideas together. So I hope I can contribute a little bit and also learn with these courses and all the events that I can attend with AOC.
Sounds good. Well, we'll see you at AOC Europe, and thanks for joining me.
Definitely. It's my pleasure. See you there.
That will conclude this episode of From the Crow's Nest. I'd like to thank my guest, Dr. Raphael Licursi, for joining me. Also, please take a moment to review, share, and subscribe to this podcast. It's always great to hear from our listeners. And if you have not done so already, we are still running the listener survey. That you can get a link to that in the show notes, wherever you download your podcast. Take a few minutes to do the survey. It helps us understand exactly the changes that we need to continue to make to the show to bring you the best possible content. And if you do complete the survey and you submit your email, you will be eligible to receive a free From the Crow's Nest podcast t-shirt while supplies last. That's it for today. Thanks for listening.